Yes, Arunji, please go ahead.
So, good morning, one and all, in the nice Saturday morning. So, happy to invite Mr. Arjunraj for the session. So, it's my indeed pleasure to invite sir, and thank you so much for your time, sir, for delivering the wonderful session to the students. I hope students were enjoying your first session. So, just to introduce Mr. P.Arjunraj, so sir is almost associated with BITS in a long-term basis. So he is a adjunct faculty and handling many courses for our WLP programs. And Sir got his mechanical engineering specialization and master's in automotive engineering from Anna Institute Chennai. And also he holds an MBA degree from Madras University, and he is a independent consultant and technical innovation and wave consultant, and he is a South Zone Council member, Indian Value Engineering Society, and he's a member Save International USA and member of many uh, agencies. And Sir is actually doing consultancy in many areas that includes electric vehicles as well. So it's a pleasure to have you here, sir. So over to you, sir.
Yeah. Thanks, sir, and thanks for the introduction and thanks for the opportunity. Good morning, all. So today we'll be covering the second part of the topic called vehicle overview. Where today I will be giving an overview about the electric vehicle in India, and then I will give the testing and standards of. I will be explaining about the testing and standards of the electric vehicle. So these two parts I will be covering today. First, going to the overview of electric vehicle in India. So before that, I want to just give a touch upon the domains and carriers in electric vehicle, where the opportunities are where we can see the opportunities are on the higher side for a carrier point of view. So with respect to the electric technology, we have a very good opportunity with respect to the power electronics and also the connected vehicles, where you can explore the lot of carriers and also even the domains where we can also do some of the research or the career opportunities as well. And similarly, electrochemistry, thermal management, power electronics, and again for uh, our application where we can also look into the material aspects, metallurgy aspects, where there are a lot of scope in these areas as well. And apart from that, there are good careers in the field of electrical machines, power electronics, control algorithms, and vehicle engineering. Okay, now coming back to the electric vehicle opportunities in India, or India, how what are the aspects that India is looking into, or what is the current trend? Let us see those things. With respect to India, the two wheeler, as far as the two wheeler is concerned, there are many big players starting from Aether to TAR. They have the different battery capacity from 2.7 kilowatt hour to up to 48 volts, and these are the different ranges of the battery capacity for these vehicles. And even the range is also on the quite good side. Maybe starting minimum will be 755 and maximum is going up to even 160 also. So these are different vehicles that is there in India with respect to the electric vehicle, and these are the different charging time that they have. Yes, there is a bit higher side with respect to charging, but considering the usage of the two wheeler, it is uh, quite normal with respect to charging point of view, because the usage of two wheeler will be maybe 25 to 25 kilometer, 30 kilometer or 50 kilometer in a week. So they can do the charging by weekend. So this 5 hours is quite normal, especially for a two-wheeler segment. But if we are taking the car segment, where the usage will be too high, and in a single shot, they will go with 100 kilometer or 200 kilometers. So sometimes the charging time is not suitable for a car application rather than two-wheeler application. So this is the top speed actually that the vehicle is having. Okay. So now let us see the very important comparison between the ether with respect to the normal 125 cc or 130 cc of the vehicle. Okay, so this is the comparison between the ether 450x and 450, and also the normal 125 cc or 110 cc conventional vehicle what you have. So the top speed is almost quite same. There is not too much difference. And with respect to uh, the, the mileage point of view, it is the range is also on the higher side, so it is going up to 85 kilometer. And you look at the power. Power is very much important. With respect to the advanced vehicle called Ether 450X, which is the modified version of Ether 450. You see here, it is 6 kilowatt is the maximum power, whereas the normal 110 cc or 125 cc is having between 5.8 to 6.8. It is also quite comparable, but you look at the price is also slightly on the higher side, and you look at the weight is quite comparable. And again, the acceleration from 0 to 60 kilometers is also quite less. And you see, in less time you can accelerate to a particular speed, and even 0 to 40 kilometers per hour as well. And so this is again the comparison with respect to the Ether 450X and Vespa Electrica and Govex and Gogaro. And these are the global leadership with respect to the two-wheeler segment is concerned. And and in India, the two-wheeler market is really good, and it is picking up to the better extent. Yeah, with respect to the three-wheeler electric vehicle is concerned, we have various models starting from Bajaj to Gaya Motorworks. Even the Piaggio is also quite good in this segment. And these are the maximum speed, and the range is again maximum it is going up to 170 kilometers. And these are the price, various price, and the charging time is also given here. So this is one vehicle which I want to touch. This is a startup company called Fitwell Mobility Private Limited. It is located in Pune, for which I was doing the consultancy with respect to the electric vehicle. So here, this is a three-wheeler segment where this is basically a startup kind of thing. The name of the vehicle is Jovi. For this particular passenger segment, it is basically passenger segment. Even they have the cargo segment as well, which I will explain to you. So they have the independent suspension, they have the lithium-ion phosphate battery, and they have a disc brake, they have the 10-speed gearbox, the steering column, and hard top roof as well. Okay. Coming back to the technical specification of this vehicle, which is there, located in Pune, it's a basically startup company, and they have the plan to manufacture 250 vehicle in a month. Okay, maybe who so any of you have belongs to Pune, you can also visit this company. Even I can also arrange for some of the internship so that it will be a good experience, practical experience as well. Okay, so this is the vehicle category where this is the different specification, and you see the range is ranging between 80 to 100 kilometers per charge. And again, they have the lithium phosphate battery, and the battery capacity is 48 volts, 80 amps hour, and the charging time is going to be 3 hours 47 minutes, and they are going to use permanent magnet motor. So I told you the various types of motor that we have in the last class as well, and the peak torque is going to be 22 newton meter, and peak power is going to be 2 kilowatt at 3,400 rpm. And the suspension, what they are going to have is a hydraulic telescopic shock absorber with the suspension and the front, and again they are also going to have the trailing arm with the helical coil spring in the rear, and the warranty is going to be 3 years, 80,000 kilometer. And these are the silent features. They have the windscreen wiping system, and USB cluster lighting, dashboard, and telematics. So telematics is going to be optional. And similarly, the same application is there for the cargo. Only thing is that the length, only there will be change with respect to this specification. The remaining aspects remain same. Only the curb weight will be slightly on the different side. Here, the curb overall gross vehicle weight is going to be 658 kg, whereas here it is going to be 670 kg. Only those difference will be there, and remaining everything remains same. And with respect to the dimensions, also slight changes will be there. It is 2,800 length and 940 and 1740 in height, and slight difference will be there with respect to the length point of view. Okay. Um, so we will see some of the things where the two-wheeler, especially first we'll start with the two-wheeler segment. What is the different type of motor controller we have? What is the battery technologies, and how about the charging station? And then we will go with the, the testings and standards for these vehicles. Okay. This is what the battery management system is concerned. You see here, you need to select a battery considering the performance, safety, specific power, specific energy, cost, and the lifespan. Even this I covered in the last class. I mentioned in the last seminar where we have talked about different type of batteries. Initially, we have the lead acid. Now we are going with lithium ion basically, and the future is going to be lithium ion polymer. And there are a lot of new technologies are coming with the state battery. Even I told you about the dual carbon battery. And but nowadays we are going with lithium ion, considering the weight. You see the lead acid which is being used initially, it is 550 kg, and now it is 180 kg, which means almost 1/3 of the weight is going to get reduced when you go for the lead acid to the lithium ion battery. Okay. So with respect to the battery management system, which is said to be the heart of the complete battery unit. So what are the different types of, what are the different functions that this BMS is going to do? It is going to be acting for the interface purpose, where you go with the status display, communication, and data logging. And the very important thing is the auxiliary and application oriented application, where you go with the pre-charging, contact control, and also cooling control. And this also helps for a protection point of view, where it protects against short circuit, overload, overcharge, and also for a deep discharge, and also for the overheating. With respect to the performance management, it helps for the temperature, current, and voltage monitoring, power safe mode, and also for the balancing. And the last important thing is the balancing, where it helps for looking at the SOC, which is nothing but the state of charge, and also SOH, which is nothing but state of health estimation. See, these are the different type of the charging station that we adopt. Not even for a four-wheeler segment, or a two-wheeler segment, or a three-wheeler segment, irrespective of that, these are a different type of charging methods we have. One is a conductive method, and one is going to be inductive method. And the conductive is going to get divided into AC and DC, and inductive is going to get divided into static and dynamic. With respect to the cost point of view, you can see the DC is going to be double the AC, and the dynamic is again going to be slightly 1.5 to 2 times higher than the static charge. And even you also have options of battery swap with respect to the cost point of view. And you see the service time is also, you look at the service time, the battery swap is very shortest, okay, which means you can remove the battery of your vehicle, and it can be two-wheeler or three-wheeler or a four-wheeler. You can simply swap the old battery with a new battery, and the time is going to be shortest. What I was doing for a two-wheeler, the 5 hours time, or for a 3 hours time for a two-wheeler, even it can be sometimes 4 to 5 hours even for a car sometimes. So in those cases, when you swap the battery, the charging time is going to be very less, and again it is going to be very user friendly as well. And let us see those aspects as well. And the efficiency is also, it is mentioned, where you get a good efficiency when you go for AC charging, conductive charging, and even you get the battery swap also, you have very good efficiency level. And even the battery lifetime is also good for a dynamic application, and followed by the AC as well. And you also have the standardization opportunities with respect to the charging application where still we can look for a dynamic charging and also the battery swapping. This is what the inductive charging I was telling. So you know the static charging where the vehicle will be charged in this static condition, and and here the dynamic condition means when the vehicle is moving at a very slow speed. Okay, so because of the EMF, electromagnetic force, when the current is getting fast and the magnetic coil, it induces the EMF. Okay, and after that, because of that EMF, you get the charging gets charged to the vehicle. This is the two-wheeler application. So this is a vehicle where the battery swapping is happening. So here you see this is the vehicle and they're removing the old battery and they remove the red one is the battery. Okay, they are removing it. Okay, and what they are going to do is this green was the new one. They are going to put this green one new battery into here, which means they are removing the old battery and they are going to put a new battery. It is nothing but a battery swap where they are switching the depleted battery with a full charged battery. What is the advantage? Okay, so you have less waiting time as you were telling. There is no range anxiety. You don't worry about the range, and you have the flexibility to charge the battery following the charging protocols as well. Again, the one. What are the cons? These are the pros and what are the different cons you have? Only the problem is you need to look for the standardization of the battery interface. We do not know whether the new battery whether it will have the same size as the old battery. That is one of the challenge. But for that, you need to do some benchmark and you need to have the battery with the same standardized size. So that is one of the disadvantage. But again, if it is not highly complex also, you can make the standardized battery. Okay? And it should be again consumer acceptance. Even the consumer should have extra battery for with them, and they should be ready for this actually. Uh, and again, the safety perspective again sometimes it's again the challenges. So these are the different business model that we have for a charging infrastructure with respect to charging and also battery swapping. So this battery swapping can be for a commercial vehicle and also for a passenger car or a two-wheeler where you have side swapping and also you can also swap it. It depends. Side swapping is basically the battery will be placed in the side area in the commercial vehicle, whereas in the case of passenger car or in a two wheeler or in a three wheeler, where it can be either bottom side or in the rear side. Considering that, you need to do the swapping. You have the onboard charging and also off-board charging, where you have AC charging spot and also DC charging spot, which can be used for a private car and also for a buses. Okay. So let us see some of the integration aspects of the two-wheeler. Okay. So what are the things it is getting affected? So let us see those things. And uh, so the affecting parameters include center of gravity during the shift and suspension, brakes, tires, safety aspects, NVH regulations. These are the things that the two-wheeler is going to experience when you are going from the conventional vehicle to the electric vehicle. You see here how the communication is going to happen. You see the blue one is a signal where the signal is happening between the vehicle sensors to the power drive unit and from the power drive unit to the DC converter and the DC load. And the next one is the electric power where the transfer is going to happen from the low voltage battery to the power drive unit and from DC converter to the low voltage battery and from low voltage to battery to the meter and from low voltage battery to the vehicle sensors. You also have the communication channel uh, in the two-wheeler where the communication is going to happen between the charger and the power drive unit. And you have the two-way communication with respect to electric power and also the communication point of view between the power drive unit and also the high voltage battery. Let us see the changes that we can experience when you're going from IC engine to the electric vehicle, especially the two-wheeler segment. Okay, the first one is the center of gravity shift. See what happens is when IC engine is getting removed and when we replace this IC engine with electric power, the center of gravity is going to be lowering. Okay, and the shift happening going to shift will get towards the front area. Okay, and and again the weight distribution gets altered and it calls for design changes in some of the vehicle where you also need to modify the suspensions, brakes, tires, etc. So this is the challenges that you need to experience when you're shifting from normal vehicle to electric vehicle. Even when you go for a new design, those are the challenges that you need to look for. And looking at the suspension point of view, it is really good actually. You have the smooth ride, you have the accurate steering, you have the good handling point of view. Even it supports the weight of the vehicle as well. So these are the different features with respect to the suspension point of view. Next, coming back to the brake point of view, you need to modify the brakes based on the vehicle weight, the vehicle type behavior, and also the load acting on the vehicle during the stopping. So you have two type of options. Either you can go for a drum brake or you can go for a disc brake. In the case of disc brake, you will be having the caliper assembly in it, where you have the disc pads, you have the disc rotors, you have the wheel studs, wheel bearing, etc. And they were looking at the drum brake, where you have the wheel cylinder, you have the brake shoes, you have the self adjuster, and also the parking brake cable, and selecting the best type of brake suitable for your application, it will serve the purpose. Next important thing is going to be the tires. This is somewhat quite challenging aspects with respect to the vehicle point of view, where because the motor is going to have the load, okay, and you need to select the motor considering the low speed or high torque or high speed or low torque, whatever it is. Okay, depending upon the various speed and torque characteristics, you need to select the tire, means the motor. So what happens is, since the load acting on the motor is, means the load, because of the load coming from the motor to the tire, there is a possibility the air chunking can happen. It means you can see the wear is happening here. Okay, and again, even the tire noise is also sometimes possible. And to overcome this, what you have to do is you need to select some of the two-wheeler vehicle where you need to go for a tread blocks like this, where you can have the different sizes to reduce the tread noise of the tire, and you need to have the less space between the blocks. You can see here to dampen the noise as well. It's not only for a two-wheeler, even for a car application, what or the three-wheeler application, what I have shown. Uh, because of the PM motor or whatever the motor you're going to select, if the load is acting into the tire, this can be experienced even for the other vehicle category as well, like three-wheeler or four-wheeler as well, apart from the two-wheeler what I was telling. So to overcome this tire issues, what you can do is you can select the best tire considering the design aspects, where you will have the less space between the blocks and to dampen the noise, or you will have the different sizes, which will also help to reduce the noise. And you can also look for different channels where you can have the grooves. The grooves, you have the grooves where it is in the circumference area, and you can also have the shoulders like this. So by selecting the different parameters, considering all these aspects, you can reduce the chunking, tire chunking, which is nothing but the wear of the tire. And with respect to the safety, yes, this is again it is quite common not only for two-wheeler. It's going to be again the danger with respect to high voltage, but again this has been already been taken care in all the vehicles, and you also have the UA and UX system, which also gives some indication if in case of any safety issues going to get arrived. So accordingly, the actions can be taken. The very important thing is NVH. You can see the graph, which is this is not only applicable for two-wheeler. It is again going to be common for two-wheeler, three-wheeler, all four-wheeler segments. See here, the engine noise is going to be higher. Okay, this is the comparison between the engine and the electric vehicle. And with respect to the electric vehicle, you can see you can get only the motor noise and also the road noise, whereas the engine noise is on the higher side when comparing to the motor noise and the road noise. You cannot avoid the road noise. Okay, this is quite you cannot avoid this, and only even the motor noise still there are a lot of researches are going on to reduce the noise of the motor, but comparatively the motor noise is lesser when compared to that of the engine noise with respect to the same speed and also the level of the noise. Okay. And you see, the powertrain noise is going to be 50%. Okay, that is quite 50% of the thing is going to happen because of the powertrain, which involves engine transmissions when you're going for this. But since we have the engine is getting eliminated and transmission, we have only single speed gearbox in some of the applications. So you get a lot of the noise benefit as well when you go for the electric vehicle. Okay. See, this is the present and future of electric vehicle in India, where you have the government and regulated bodies, where the DIU is coming into picture. You have Ministry of Road and Transport and Highways. All these government bodies is helping for the increase of the vehicle generation with respect to the uh, just a second. Yeah. So here, where the government policies are coming into picture with respect to the India, the road and transport, with respect to the different regulatory bodies you have. And next, coming back to the different segments, where you also have the charging infrastructures, which is going to be a very important thing. I was told you about different charging methods: AC, DC, inductive, conductive, and battery swapping. So you have the different companies like which includes ABB, Fortran, High Sun Mobility. You also have some of the electricity providers and utilities, which involves the companies like Tata Power, NTPC, and Indian Oil as well. And there are different companies with respect to battery technologies which are available in India, which includes Denso, Nippo, Ion, Sun Mobility, Sukam Power Systems, etc. And these are the different automotive manufacturers you have. Mahindra and Mahindra for a two-wheeler and also even the three-wheeler segment they have. Ashok Leyland, Bajaj Automotive, Ether, which I was showing, Ampere vehicle in Coimbatore. And you also have the Hero Motorcorp. So all these vehicle, they are into the manufacturing segment. And apart from that, a lot of startup companies are there. I've shown you some of the startup company which includes Super Mobility. Even you have Yulu bikes, okay? They are into two-wheeler segment in which is located in Bangalore. Even if some of you belongs to Bangalore, I can help actually for some of the internship as well in Yulu bikes as well. Okay. So there are a lot of opportunities where the startup companies also coming with respect to the electric vehicle. And with respect to the user's point of view, where you have the public sector, where the market actors are using with respect to different the state transport corporations, different like which involves Himachal Pradesh, even Bangalore BMTC is also using this. And again, you have different service providers which involves Ola cabs, Uber, even the Joomla, DHL, and you also have the lithium urban technologies as well with respect to the mobility service providers. And you have the ecosystem of financiers where you have different companies, different banks also helping the companies with respect to the financing aspects. There are different things, even for the fitful mobility, what I was telling. Uh, there are different financial companies, even for Eurobikes, it's a new company, it's a startup company. Even for Ether Energy, there are different financial companies are helping helping the company and also helping the seekers who want to buy those vehicles. Okay, they are giving some EMI loan options as well to buy those vehicles as well. Let us go for different second part of today's seminar, which is very important. Is which we are going to see the test and standards, different tests what we have, different standards, different homologation point of view. What are those things? Let us see those. So the second part of today's seminar is going to be different tests for electric vehicle. Okay, before going for the test, what we have to go is what are the factors which is affecting or affects the electric vehicle durability. Okay, so we need to do the testing. Basically, we need to follow the standards basically to achieve the durability and reliability of the vehicle. So let us see what are the factors which will have the influence over the electric vehicle durability. The depth of discharge of the battery is going to have, and the state of charge of the battery, charging rate, and the driving cycle. What is the cycle that we are going to follow? Okay, whether it is going to be a city or highway or different combination of the different cycle, and what is the temperature of the system, how the driver is going to drive the vehicle. Okay, whether the driver accelerates very fast and the braking effect, etc. So all these things need to consider when you're considering the electric vehicle durability. Okay, the depth of discharge is nothing but the percentage of the total energy which is left in the battery. State of charge also, which we have seen, which is nothing but the level of charge of the battery when the vehicle is in the standby mode. And the meaning of the charging rate, which is nothing but the rate at which the battery is being charged. And even the other two aspects, environment is also very much important. At what condition you are driving the electric vehicle? Is it running? Are you going to run the vehicle in hot condition or dry condition or cold condition or snow condition? Even altitude also matters. Whether you are going to run the vehicle in different gradient, different scenario, those things are also very much important. And what is the daily usage? What is the number of miles that you are going to run? I was telling about you the two wheeler, okay, where you can use the two wheeler for your work to office, office to work, I mean home to office and office to home, where you can daily you can cover maximum of 20 or 25 kilometer. So or even for some of the people who are 10 kilometers also will be using it. Okay, so if that is the case, what you can use depending upon the daily usage, even that will also have the influence over the article durability. And these are the different testing methodologies that you need to look when you're going for electric vehicle. The first one is going to be the elevated storage temperature, where the vehicle will be stored at an elevated ambient temperature for about 2 months. The capacity will be tested. They will be testing with respect to the different capacities weekly to determine the loss of capacity as well. This is the methodologies that all the OEMs they also follow, and the methodology is elevated storage temperature. And next methodology is going to be rapid charge and discharge, where the vehicle will be charged and discharged at a much faster rate than normal for about 20 cycles without any rest period between the cycles. We also have the thermal shock cycling, where the vehicle will be quickly cycled from high temperature environment, say for example 80 degree to a cold temperature environment of minus 40 degree for about 5 cycles. So you have this methodology, testing methodology as well. So the very important thing is the vibration. As I was comparing the noise between the conventional vehicle and the electric vehicle, even the vibration is also very much important. Where the electric vehicle will be placed onto the vibration shaker, as we call it as a shaker table, and it will be subjected to a series of vibration for a particular period of time. So the natural frequency of any system. Okay? So whatever the natural frequency, what you are going to experience, it can be from the motor or from the battery or from the controller or from the BMS system or from the complete vehicle structure. Okay, so those natural frequency, you need to ensure that which is going to be higher than the original the frequency what the overall vehicle is going to experience. And if in case if the natural frequency is going to be lesser, then what happens is, or if it is going to be equal to that of the original frequency, then the resonance can happen. As a result of that, the vibration can get experienced. So you need to do the vibration testing. All these testings are very much important. And last important thing is the end of life vehicle, and also you also have different type of battery testing as well. This normally we are going to do this testing on a hybrid electric vehicle, where it's not only hybrid electric vehicle, even battery electric vehicle as well, where it is going to get accumulated after 1,60,000 kilometer or miles. Okay, you need to do the test considering the end of life and also the battery test. You characterize the different scenario or different parameters of the battery with respect to the fuel efficiency and also the traction battery pack capacity. So these are the integration system and also different systems that you have. Especially, you need to look at the different integration when you look for a complete vehicle as well. So where you go for a suspension, brake, steering, drivetrain, powertrain, HVAC, vehicle body, electrical, and also the interiors. So when you do the testing or any durability aspects, so it's not that you do individually. Yes, you of course you do the test individually. You have the design verification plan for the individual system, but finally you need to integrate all these things into a complete vehicle. Then you need to do the complete durability or a reliability test or validation test, what you call, with respect to the different methodologies, what I was telling you, different factors. So considering that, what you have to do is you need to integrate all these things, and you need to overall look for safety, weight management, dimension aspects, so ergonomics also, energy, even the regulation. So the topic what I was discussing today is not only testing, but even the regulation also we will see the standards. So all these things we need to ensure that all these areas are getting integrated with respect to the systems and also with respect to the parameters, okay, which involves from safety to the benchmark. Even we can also look for some of the benchmarking aspects, how the other vehicle has integrated, and considering that as a benchmark, we can also ensure that your vehicle durability or your vehicle reliability is going to get improved. This is the normal manual transmission. We also have the automatic transmission. You have the continuous variable transmission. You have hybrid electric vehicle. You have the transmission components for a PTO, power takeoff, etc. So for all these different things, okay, now our area of interest is going to be electric and hybrid electric vehicle. For any vehicle, what you have to do is you have to do the static test and also the dynamic test. Okay, where in the case of static test, you do the durability and wear test, performance and efficiency test, NVH test, altitude test, climatic condition test, thermal and lubrication test. Yeah, this is not only applicable to one particular segment. Okay, so you might be seen a lot of tests with respect to the conventional vehicle have manual or automatic or even the CVT or PTO. But it is not unique only for the conventional, or it is not unique only for electric vehicle. So all the tests needs to be carried out with respect to both static condition and also dynamic condition for all vehicle category. And yes, now we are going to deal about the electric vehicles. Yes, in electric vehicle we do all these tests as well. In dynamic condition in electric vehicle we do the start test. We also do a lot of functional testing with respect to the battery, motor, and the torque, power characteristics, etc. We also we also have some of the durability test, like with respect to the different conditions. We also do the testing, and we also do some calibration with respect to the different shifting conditions. But this shifting is, as I said, you are going to have only single speed gearbox, and but here you see you have different shifting. So the durability for a transmission is uh, quite different in the case of conventional vehicle, where you need to do a lot of shifting tests, calibration tests, etc. Whereas here in electric vehicle, the condition is slightly more focused towards the motor or to the battery system or to the complete powertrain, where you are going to ensure that the efficiency, the performance, and the durability is going to get met with respect to different altitude condition and also different environmental condition. So here, the very important thing is the energy and battery management system, and there are different type of simulation is also being carried out for a electric vehicle, where how that cornering is going to happen, for a vehicle, because as I was telling you, the weight acting onto the tire because of the battery is on the higher side to some of the vehicle. As a result of that, when you corner the vehicle, what happens? There is also challenge, okay, because the tire, when it is cornering, it also need to go either to the left direction or to the right direction, or to the direction what the, the driver is operating the vehicle. So even for there are some challenges even with respect to the dynamic condition, especially when the vehicle is assume that when the vehicle is going to run at 100 kilometers per hour, and if because of some emergency, if the vehicle have to turn, okay, corner, okay, even at a high speed or low speed, okay, I told you the load acting onto the tire is also on the higher side. These are some of the challenges that some of the simulation also we need to do, and we need to take the actions accordingly. Okay. So with respect to the verification and validation of electric vehicle, so as I was telling, the performance is important, endurance important, the reliability, durability is important, safety, end of life is very important. So these are the conditions that we need to look when we are going for VNV activities. Where here what we do is, we do the testing considering the customer usage, how the customer will use the vehicle, with what condition, what is the different speed at which they drive, what is the different condition they drive, and what is the charging infrastructure that they're going to have, depend upon different operating terrains as well. Sometimes you take Uti or Manali or Jammu Kashmir, or what is the terrain, okay, where on which area they are going to operate. Considering those things also, we do the verification and validation. And again, the snow condition, it is going to run in snow condition, or in a foggy condition, or in a high temperature. So considering that also we do the some of the things. Even there are some vehicle which will get operated in the seashore area, where they do some of the salt spray test as well for your vehicle, for some of the outer area, because when you are running the vehicle in the seashore area, where you have the salt content in the water, which is coming the water from the sea into the air, from the air when it is striking the vehicle, okay, because the air continuously moves, right? Even the that's why you do some of the salt spray test also, okay? Depending upon the vehicle condition where you are going to use the vehicle, uh, we also need to do the verification and validation, and it is not quite unique as I was telling. These are quite common for conventional vehicle and also for electric vehicle. But here, even the safety is very important, because I told you the voltage, and because we have a battery system here. So this is something we need to look into it. So okay, so with respect to the output, what we are going to get is, we are going to see the traction efficiency, overall traction efficiency with respect to speed, torque, etc. And we are going to analyze the NVH parameters. We are going to analyze the temperature point of view. We are also going to analyze the drive cycle estimation with respect to the energy consumption. So you have different drive cycle. You have an Indian driving cycle for Indian application. You have European driving cycle. You also have the world harmonized, the American driving cycle. Also you have, so considering the different driving cycle, you also need to ensure that how much is the energy getting consumed with respect to the different drive cycle. In India, the average speed is going to be 90 kilometer per hour, whereas in the case of Europe, it is going to be 120 kilometer per hour, whereas in the case of USA, it is going to be 140 kilometer per hour. So this is the different average speed that different countries is going to follow. Similarly, Japan and different countries is also having the different driving conditions, or the average speed condition. So accordingly, depending upon the condition, that's what where the vehicle is going to get used. Okay, you need to understand the customer users. So accordingly, you also need to design your vehicle, and once you design, you get the output. According to that output, you get according to the input you design, you get the output, and the output you are going to confirm with help of all this testing. Then the very important thing is the battery testing and power electronics testing. And in the case of battery, you go with the propulsion, regenerative, or a charging test, and you have the estimation with respect to health and the life cycle. The very important thing is the power electronics, where you go test with respect to EMA test, EMC test, and specific energy consumption test. Okay. Um, Let us go to the electric vehicle ecosystem development. Um, so how the electric vehicle is getting developed? uh, starting from the R&D to the market. Okay, so here in the case of battery, in the case of R&D, what we do is we do look into different types of battery options, raw material for the batteries. We have different raw materials. Then we go for a component level where we go for a battery cell, motors, power electronics. Then we go for a subsystem where we develop the battery modules, motors, power electronics modules. Then we go for a system. You see how it is going step by step upward. Then it's a system where you go for a battery pack, traction system, power electronic system. Then in OEM we are going to integrate. I told you all the integration areas. Okay, you are going to integrate it. You are going to do all these tests with respect to thermal, electrical, mechanical safety. And then you are going to finally go for your recycling. See, even you can also get the battery getting recycled. Even you can sell the batteries also. Okay. There are a lot of companies where they're getting the used batteries and they are going to recycle it. And even it is also a big business for those companies as well. Okay. This is the development value chain. And when you look at the value chain of the complete electric vehicle industry, it is nothing but a complete ecosystem of EV vehicle. So you start with again going to be development where you're going to develop in-house, where you also have some other technology transfer. You also have MOUs with different R&D centers, different research institutes, and you also have some of the partnership between companies and also some of the consulting agencies as well. And they are going to do the sourcing. Okay, they are going to get different batteries or different motors or different control systems, different components from different companies. They're going to do it can be either localized in India or it can be it can be coming from different countries as well. And you need to do the assembly where you go for some semi-automated or fully automated assembly. You can also go for some of the contracting manufacturing, subcontract manufacturing as well. Then you have to distribute it. Then you go for a repairing. Then you go for aftermarket. So this is the chain which is happening in India. It's not only in India; it is quite global. Also, they also have some of the AMC, which is nothing but annual maintenance contract. There are some areas where you can also pay based on the kilometers how much you are going to use as well. Let us concentrate now on to the regulations and testing again. In India, you have, as I was telling, with respect to the MORTH initially, the Ministry of Road Transport and Highways, they are the governing authorities to, for the regulation point of view in India. Basically, this is structure that we have with respect to the framework of the regulations and the different agencies that we involve with respect to the industry standards for automotive vehicle. So the overall governing is going to be Ministry of Road Transport and Highways, and here they are going to deal about Motor Vehicle Act and also CMVR, which is nothing but Central Motor Vehicle Rules. Even the regulation or homologation, what we call is nothing but CMVR or homologation, which is related to the Central Motor Vehicle Rule. And here they form a committee called Technical Standing Committee, which they will be giving the guidelines and all the technical inputs to MORTH and what this committee is having is they have three associations. One is industry association, next is going to be testing agency association, and again industry associations. You know, as far as industry association is concerned, we have the SIAM, which is nothing but Society of Indian Automobile Manufacturers. We also have Automotive Components Manufacturer Associations. We also have the Tractor Manufacturing Association, and also each and every state is having the transport departments as well. So all this is a part of industry associations, and this technical standing committee will be going to the each and every individual association, and they will be taking their inputs, and it will be a two-way communications, and all this will be given to the Ministry of Road and Transport. And you have different testing agencies. So you might be knowing about ARAI. Is the Automotive Research Association of India, which is located in Pune. They do all the testings, all the homologations also they carry out. Is one of the certifying body that you have in India, where you also need to get a certificate before you go for any launching the vehicle from any of these testing agencies. One is ARAI and another is IGAT, International Center for Automotive Technologies. You also have the VRD, as well. And these are the different ministry associations where you have BIS, which is nothing but Bureau of Indian Standards, and Ministry of Heavy Industries and Public Enterprises as well. Okay. Let us see what are the different tests that RI is going to do as per this one. Okay. This is AAS 123. As per this, you are going to do all these tests. Okay. These are different type of tests actually. Starts with the vehicle weight, coast down test, indication test, gradability test, electric range measurement test, brake performance test, MEH test, EMC test, traction motor test, battery test, wiring harness test, and also the different functional and consistency test as well. Um, these are the different tests that you do. This is a PDF document where you go with the range and the energy consumption test, motor power test, where you do the test for a maximum power test of 30 minutes, how much you are going to get the power. You go for EMC test, post down test, and you also do the vehicle impact test as well. Okay, sled testing you do the thermal durability test, thermal mapping test, you do the start stop test. Okay, because the battery, no, battery you have and for to understand the reliability of the battery, you also do the start stop test as well. The fatigue test you do. You also do the braking test. You have the vehicle environmental test where you do the water flood test and drain shower test. And you also turning circle time the test. So I was telling the cornering will be somewhat a big challenging, right? So for that you do this cornering test as well. These are different type of tests that you have. And again, I told you you have different test cycle that is being followed in different countries. In India, you follow any Indian driving cycle, whereas in the case of the Europe, you follow new European driving cycle where the vehicle speed is average speed is going to be 120 kilometer per hour. You follow different test cycle for different country, different conditions. This is the different cycle that we follow for a two wheeler and three wheeler, where the maximum speed is going to be 40 or and I told you the overall average speed is going to be 90 kilometer per hour. Maximum average speed, okay, 80, 90. This is at these different conditions. You also test the vehicle. Okay, let us see the presentation. See, you also need to evaluate and because how you can determine this, okay, based on evaluation and different standards, okay, different standards as well. So I told you about European driving cycle. I told you about the US driving cycle as well. In Japan also they follow different cycles. Okay, and these are different driving cycles that for different countries going to follow, and they have their own guidelines. So this is the new European driving cycle where I told 120 kilometer per hour is average, and you also have different cycle test cycle where you follow. Here it is for a old harmonics light transient condition with drive cycle, and this is again going to be a European driving cycle for a car segment. Yeah, for hybrid and electric vehicle, you go for the test cycle where you have the range where you also have. I told you about parallel hybrid vehicle and also serious hybrid vehicle. So considering the different application, if it is parallel, which is highlighted in green, and if it is serious, it is highlighted in red. But here, assuming that it is going to run in parallel hybrid electric vehicle conditions. So with respect to different timing and different speed, you'll be testing your vehicle. And this is a test cycle that normally you follow, and this is nothing but the electric vehicle mode, where it is highlighted in blue. Okay, so this test procedure you follow for a hybrid and electric vehicle. Okay, so for the vehicle, I told you about the Fitwell Mobility. Okay, that is a three-wheeler which is in Pune. They have done a drive cycle simulation. Okay, they have done a testing in a place called Sahakar Nagar to Saram. Okay, they have done the tests. Okay, and they have done the simulation also. This is the different timings they have done the test. Okay, and this is the different vehicles speed. Okay, um, they experience means and here this is the average speed. Okay, which has been applicable for a two-wheeler, three-wheeler, or a car segment, okay, which is running in this area. And this is the simulation that is being carried out, or this is the different simulation which is being done with the help of the tools. And considering this as an input, they have done the durability for their vehicle. Okay, I'll show you the vehicle also. And this is the Sakar Nagar Pune drive cycle, where the maximum is going to be 60 for 70 kilometer per hour for a different vehicle category. Okay, and they also have different elevations as well, because the road is not going to be even, right? So you need to analyze. That's what I told you. You need to do the analysis at which road condition you are going to do the testing, and considering that, you also need to do the evaluation testing. Sometimes you also conduct the worst case, so that you can get the best performance for your vehicle. See here, the gradient is going to be, elevation is going to be higher, and the elevation is also going to be down as well. Okay, so when the elevation is on the higher side, where the hilly area you can experience. Okay, so in those areas, so when the vehicle is going to run in the big altitude area, where the torque, those issues might come. Okay, so how you are going to experience that? Okay, those are the challenges, and the gradient as well. This is the drive cycle that we have arrived, and this is also one of the place called Sakar Nagar to FC Road, and this is the different elevations that is being simulated. So now, with respect to the different test cycle, what I was showing, what is that all about? Okay, this is nothing but WLTP. What is nothing but the World Harmonized Light Test Procedure. So this two-wheeler or a four-wheeler or a passenger car, okay, it is coming under a worldwide harmonized light vehicle test procedure category, where it is been um, considered with respect to the different conditions, different test scenario with respect to here we don't have the fuel consumption, but here we also look into the consumption of the energy, battery energy consumption. We also have we also measure, but here we measure the energy consumption. That's what I told, which is an alternative to the normal conventional powertrain vehicle. In the world test, you have the new European driving cycle, where I told you 120 km per hour is the average speed. In the case of new test, this NEDC has been replaced, where you have WLTP, where it is matching the better with respect to the road performance or the road conditions as well. Okay, so these are all the different conditions with respect to time, with respect to speed, with respect to acceleration, with respect to start-stop conditions. You need to do the kinematics test as well. Okay, and all these are dynamics related tests, where you need to do the different tests for your vehicle, and you follow the different test cycle also. Okay, so this is very much important. Uh, the homologation, okay, the standards for two-wheeler, three-wheeler, e-rickshaws, four-wheeler buses, and all these standards are been coming under CMUR, which is nothing but Center Motor Vehicle uh, regulations. And so these are the different standards you have for electric vehicle, hybrid electric vehicle, even for a retrofitment of the battery, and also for electric vehicle category as well. Another 10 minutes to complete, so that you can ask your questions afterwards. Yeah. So the very important thing is, these are the different CMBR regulations and different regulation numbers that we have. Let's see those things now. Yeah. So you have the AAS standard 038, which is related to the requirement for a construction and functional safety. For our for our battery electric vehicle or hybrid electric vehicle, the electrical energy consumption is going to be very much important. Where the unit is going to be watts hour per kilometer. This test is important, and they do the homologation with respect to this test actually. And they also do the measurement test, where they will be measuring the range of the vehicle, and they also do the EMC test. They do the electric powertrain vehicle measurement test. to understand what is the net power they are going to get, what is the maximum 30 minutes power. So they will be testing the vehicle for 30 minutes, and after 30 minutes, what is the power that the vehicle is going to experience. And they have AS048 where that is related to safety aspects of traction batteries. You also have the charging stations standards. You also have the CMER for a hybrid and electric vehicle. You have AS 123 where it is applicable for a retrofitment onto the vehicle. Okay, so these are the different test procedures and different regulations I was telling for AS 038, 39, 40, 41, 49, 48. So these are been mainly used for uh, electric vehicle. The very important I was telling you it's AS039 where you are going to test the electric energy consumption. This is for a two-wheeler. Okay, what they will do is they will be testing the two-wheeler in a chassis dynamometer. It is not only two-wheeler; it can be for a three-wheeler or a four-wheeler, okay, or a commercial vehicle or truck application. Okay, what they will be doing is they will be taking the vehicle to a chassis dynamometer where they will be doing the measurement, and they will be measuring what the energy required for the vehicle to travel for one particular kilometer. So they will be measuring that in terms of watts hour per kilometer. They have the range. Okay, they will be verifying whether the range is meeting the specification or not. Considering that, they will be giving the certificate whether this test is passed or not. Okay. Next is going to be again the measurement of range. Okay. So in a single charge, okay, in a single charge of your battery, how much is the maximum range that the vehicle can drive? It can be for two-wheeler or three-wheeler or four-wheeler or a commercial vehicle. Okay. Uh, at a single charge, what is the maximum range that you are going to experience? That you are going to measure on the same cases. Next, we are going to do the maximum power test. This is what I told you. You are going to do the test for 30 minutes. Measurement is going to be for 30 minutes, where you are going to measure the speed versus power. And here you have different test chambers as well. You also go with the different capacity like 150 kilowatt or 220 kilowatt electric motor test. You have the in this test bed you do this power test actually. Where you also do the motor characterization test, the power, speed, the speed, the torque characteristics also you can get it. You can also understand the reliability, durability, and also the overload capacity in this test. And you also have some of the specific requirement tests like which is coming under AIS 049, which is related to the brake performance and also the regenerative braking. Last class, some of you are asking about regenerative braking. It is nothing but when you apply the brake, what happens is it's basically friction, right? So what happens? Uh, the kinetic energy, basically, kinetic energy is nothing but half mv square. When the velocity is getting reduced, okay, when you apply the brake, velocity gets reduced, the velocity of the vehicle gets reduced, and the friction is going to get. You apply the brake, you are going to hold your vehicle. Means you are going to hold your tire wheel. Okay, so what happens? The friction is going to happen, and this mechanical energy, which is nothing but a half mv square velocity. Okay, after that, what happens? That you are going to convert that into a mechanical energy into electric energy, where that electric energy is used for charging your battery, and that in turn be used for your vehicle application. So they do the test and performance test with respect to the regenerative braking at a different. Here they will be starting the vehicle, stopping the vehicle. They will be looking at a different regenerative braking aspect, and they will be doing the test. And they will be seeing how much is the charge that they are going to get with the help of this testing. And they also do the gradability test, considering the different state of charge. See, it is you see here, they're not going to do the gradability test at 100% state of charge. See, state of charge is the one where it is it is sometimes even at the minimum or at the lower level of state of charge, how the gradability is going to experience. They are going to do the noise test, they are going to do the EMG test, they are going to do the speedometer calibration test, everything. And these are the different test procedures when we need to do for a electric vehicle evaluation, where they do the and So this is the applications of electrically powered road vehicle where they're using the lithium-ion traction battery management system. Okay, and there are different even you have the individual standards. SAE, Society of Automotive Engineers standards you have even for batteries alone. You see this much standards you have for a battery alone. Okay, where you are going to look at different performance of the battery, rating of the batteries, storage of the batteries, even the labeling. Okay, you have the guidelines for that as well. For determining the maximum power, you have the guideline. Even for the vibration test for the battery alone, you have the standards. You also have the abusing test for the battery. You have the life cycle test for the battery. You have also some of the magnetic and electric field strength for standard you have. You also have, I told you about EMC test, okay, electromagnetic compatibility test, even your test procedure. You need to do all these things to ensure that only for battery alone. Okay, you see, this much we are doing for that. You see, this is the electric vehicle standards. In India, you have the ARAI, as I was telling, where you can do the testing for two wheeler, three wheeler, four wheeler, and you have the standards also. Okay, and you need to ensure that all these standards have been met. That is the existing standards, and so even they are going to revise the standards as well. Whenever it is required with respect to the safety or with respect to the vibration or with respect to the durability or with respect to the charging or whatever it is. Okay? They keep on changing the standards once in a while. Maybe 3 years once they will change the standards because they are going to change the standards considering the different conditions that the vehicle is going to test at the field. And here you also have some of the things with respect to battery packaging, the charging systems, and also the plugging systems and the coupler systems. And you have the National Electric Board Standard (NEC) for electric vehicle charging system. You have SAE J2293 for energy transfer system for electric vehicle. You also have J2836, which is recommended for communication plug-in and also for utility grid. You have the coupler standards. You have the charging, conductive and inductive charging. And finally, you also have IEEE standards for interconnecting the various resources with respect to the electric power systems as well. This is what I told you, different type of charging. You have AC, and also inductive charging, DC charging, etc. And even you have the battery swapping as well. And even you also have the individual standards. Okay, you also have the individual standards. And again, the standards will have different class, different rating, power rating. And how the communication is going to happen? Is it going to be a pilot, a control pilot, or is going to have whether the transfer of the power or charging is going to happen from station? How it is going to happen? Is it going to be a pilot operator, or is it going to be a power line operator, or is it going to be wireless operator? Because we also have the wireless charging, right? So here in the case of inductive, as what I was telling, when the vehicle is moving, okay, here is basically wireless charging. Okay, so that's why for each and everything you have the standards, you have the procedures as well. And in the case of the discharging, this is the one where you have the power line. Okay, this is the station where the charging is going to happen with the power line. And you also have the pilot. Okay, so this is the plug connector kind of thing. So you have the you can follow this coupler kind of thing, the grid kind of thing. Maybe I'm not able to get that image. Yeah, you can see here. Okay, where I was highlighting. Okay, you can see the plug connector where you can connect it to charge your battery. Also, as I was telling you, have the SAE international standards, which is helping for a coherent system, transparency system, effectiveness system. For it is again helping the complete thing to overcome the barrier, technical barrier. And this standard we are following SAE standards. Worldwide, we are following these standards. And this is a new era of mobility where we are going to vehicle integration. We are going to vehicle to device P2G. So even in future, this is vehicle to grid where this application for charging systems is going to come. Even you are going to have the vehicle to infrastructure. You see, these are going to be a new era of mobility where you are going to have the electrified automobile, where you are going to have the electric smart grid, and where you are going to have the connected and autonomous vehicle. These are all the features of electrification where based on this consumer needs, you are going to develop the technology, you are going to have the new infrastructure, and you are also the challenges is also there, and even the regulation is even changing. Even the SAE or RI, whatever the standards, even they keep on changing the regulations. They're adding the different requirements. So these are some of the challenges, but we are going for a successful implementation. Yes, this is going to be every time, all the time. So the implementation is going to happen. Only thing is that the charging is somewhat the big problem for many of the Indian application as far as is concerned. So is it going to work every time or all the time? That is one of the challenges. But yes, we are going towards the future of electrification, which is going to be successful as per the research. So these are the different electric vehicle technologies which we need to collaborate, and we also need to get some of the collaboration and also the technology enabling systems for which we can move towards the conversion to the electric vehicle. Where we need to have the research oriented thing, where we also need to have the standards, where we need to have the collaborative efforts. Um, yeah. So I told you about different vehicle battery standards. Okay. So you also have a standing committee for each and everything, like for a battery, for a power controller, motor. So you have this steering committee. See, one committee will look at battery safety, one committee will look at the packaging, one committee will look at labeling, one committee will look at the transportation, the starting system, how it has been connected, disconnected. So this is how you see you have totally 18 committees for battery alone. Okay, and these committees will be forming from different companies, 140 companies, and they will be from different companies, suppliers, tier one companies or different OEMs. They are also from government agencies will be the part of that, even academic institution. Everybody will be a part of this, and you also need to link the standards with respect to the different SAE, ISO. You also need to link the standards with respect to the charging system, battery system, controller system, uh, safety systems, traction systems, powertrain systems, etc. So this is what I was telling you, the plug-in system, the pilot operator one. Okay, you see, you need to follow this guideline for charging your vehicle. This kind of plug, and you see the connector how it is there. It's a pilot one. Even you have different standards for this connector, for how it is getting communicated, how the topology is being done. These are the different SAE J2931 bar 1, 2, 3 up to 7 you have, where each and every standard is having different scope, starting from power line carrier communication to the security of plug-in LTV communication. You have different scope, different analysis for which you need to look at the individual standards accordingly. You need to achieve this scope. You will be doing the test, but to ensure that this scope is being met, all this test procedure, whether the standard is being met or not. It is not that we do only few tests alone. You see, there are a lot of things, right? Even you do the supporting tests with respect to your electric vehicle or hybrid electric vehicle or plug-in hybrid electric vehicle. So you have different standards. So thanks for an opportunity, and even you can email me or you can also contact me at 877898248. My my email ID is p.arjunraj@gmail.com. See, what I will do is before going for question and answer session, so I will show you the vehicle of the Fitwell Mobility. I will show you the video of how they do the gradient test in their company, and then what are the tests that they have done or they are going to do in ICAT, okay, Center of Automotive Technology. I will show you that, and then you can go for a question and answer session. First, I will show you the different tests that is being planned for this vehicle. Uh, they are going to do the test in International Center for Automotive Technology, ICAT. Okay, it is also a part of the NATRI. Okay, I told you the company located in Pune. Um, this is nothing confidential here. So this is a test that normally all the three wheeler will they will be doing it. So we have seen the fame. Okay, last class we have seen, and this is coming under three wheeler category. And these are all the different tests that they are going to do. You see, different tests they are going to do. One is going to be the radiated emission measurement test, and you're going to do the certification charges for your e-rickshaw. And again, the CMER for physical verification, documentation for the vehicle, and the parking brake credibility test, the noise test, pass by noise test, and you also have the hill track test, and you have the vehicle weight non-CV test. You have the energy consumption test, what I was telling you. The kilometer means watts hour per kilometer. That test you are going to do. You are also going to do the range test of the vehicle, and you are going to do the test track hiring charges. All these things you are going to do for a noise application. Even they also do the photography. They will be taking a photograph of your vehicle at different angle, and so all these are a document kind of thing. Okay, you see overall test charge itself it comes around 8,16,000. So this is only for the three wheeler. Okay, so when you go for a four wheeler, you see the complexity gets doubled. Complexity means the testing requirements, those things will get. And you see, this is the different number of tests also. What is the number of tests that you need to? What is the number of hours? Okay, so for these hours, okay. So considering this, they will be also charging. Okay, so this is one of the thing which I want to show to you, and I have one video as well. How they are doing uh, the test at their company for a gradient level point of view. You see here, this is the vehicle. Okay, if they are going to do the gradient test. They are going to do the gradient test. You see here, um, uh, there are three passengers sitting at the back and one passenger sitting at the front. So you see the load is going to be higher, right? See, and again, when you are taking the vehicle upward, what happens is it is very important that you are not going to topple down or up. Okay, it is very basic, risky again. So you see here, you can experience. Okay, the vehicle is getting slightly bending back, but again you see, yeah, this is the one the gradient test that they will follow, and even they also do some of the test which includes the test in the city conditions, test in with respect to the different even some of the things even to check um, your the conditions. They also do it in different road conditions, different terrain conditions also. Yeah, so with this I would like to close, and if any questions you can ask now.
Thank you so much for your detailed presentation, sir, and hope the students enjoyed it a lot. Personally, I enjoyed it throughout the session. We have a couple of interesting questions, sir. Um,
Yeah.
so the first question is from Mr. Srinivas. He's asking, due to EVs, electric vehicles, I think there will be a drastic increase in power demand to charge your batteries and usage of renewable sources, or very less. And how can we face this challenge?
Okay.
You want me to repeat it, sir?
Yeah. What I understood is the power demand, how we are going to experience, how we are going to overcome it. Okay. So here, what happens is There will not be any power demand. Basically, India is having a good resource with respect to coal or the energy aspects. Okay? And only thing is that we are encouraging, means the government or the manufacturer is encouraging the customer or encouraging the people to go for a electric vehicle rather than looking at the old conventional one. Um, yeah, yeah, with respect to the demand or the power demand, there will not be an issue. Only thing is that the charging infrastructure is going to be challenging. As I was telling, the, you need to wait for 4 hours or 5 hours. That is where the problem comes into picture. The charging technology is one of the problem, but again for that we are going to have inductive or conductive or the dynamic charging or a battery swapping technologies. So only this is going to be charging is going to be challenged rather than the power demand. So there is no issue with respect to the power demand, especially because it is not that the world generation like maybe decades back or decades back where there was a power issues, but nowadays the power issue is not a problem, and only the problem is with respect to the charging system. But again, the technology is getting developed. Even all the OEMs or even different research agencies are coming up with new technologies with respect to charging application.
So the second question is how the vibration will affect the battery.
Okay. Um, yes. See, it's not only that vibration is going to have an influence over the battery; it's complete system as well. You see here, as I was telling, the location of the battery where it is going to get mounted. Okay, you have a separate mounting location for the battery. So as I was telling, the weight of the battery is also quite going to be, say, for example, 180 kg, or the weight is going to be much more higher. When I say the weight is going to be higher, and the overall the weight of the vehicle, and again the overall weight of the battery, and when it is going to experience the vibration, you need to have you need to ensure that there does not be any crack or any leakage in the battery because of this vibration. That's why we need to do the testing. And again, the battery is having all the chemical in it. Again, because of vibration, if there is any crack or any leakage, okay, even that will also be a big challenging task, which will affect the environment. Again, it's again will be hazardous sometimes. Okay, hazardous. That's why the battery safety, everything comes into picture. But this vibration is quite important because the weight of the battery is going to be higher. Considering that weight in dynamic condition, we need to look at the natural frequency of the battery. You need to ensure that the overall natural frequency of the battery should be higher than the natural frequency of the vehicle. Okay, if the natural frequency of the battery is lesser than the natural frequency of the vehicle, then obviously there is a possibility the battery can fail with respect to the vibration point of view. It can experience some of the crack, or it can experience some of the damage with respect to vibration point of view. That's why you do some of the tests individually as well. When you are doing the vibration test, you measure the vibration, how much is the vibration which is getting experienced in battery, motor, and even in controller, or in your tire, sorry, in your chassis, or in your vehicle body. Okay, so at different location you also measure the natural frequency, and you need to ensure that overall natural means the individual natural frequency should be higher than the overall natural frequency of your vehicle. And battery is very important because we need to do the vibration, and it will have the influence over safety aspects as well.
Thank you for the answer, sir. Sir, we have one more question. Um, I'll come to that question later. Before that, we have Mr. Sai Gopal's question. Nowadays, since people are talking about charging at home itself for normal domestic socket, what special features the battery needs to have to accommodate this feature?
Yes, nowadays what happens, even some you can see in the places like Mumbai, what they in big apartments and all, what they are planning is they already have the system where uh, they have the home charger, where even they have their charging system in the parking area in the big apartment. So even some of the things what they're doing is they're taking the source of power from their home, and even they're taking that as an input, and they're charging even for some of the individual houses as well. Apart from apartment, they are also doing these facilities. And with respect to um, the adaptation, as far as adaptation is concerned, what is the future that you need to add is uh, the connector connecting means that you have the socket, and those adaptation you need to look into it. And the only thing is that how how fast we are going to uh, ensure that what is the charging time. Okay, those things we need to look into it. But the challenges here is the distance between the vehicle and the input source. Okay, if the input source is nothing but your the place of your residence. Okay, so they have what they have different ranges or different distance. Okay, the distance is going to be higher. Accordingly, we need to have the length of the connectors, or the wire which is going for the connection point of view. Those things also we need to take there. But this is not going to be much more challenging. And again, this has been already been used in places like Mumbai, where they have the residents. You can also check it in internet, where you have Mumbai residents uh, charging system. Okay, so especially in the places like big apartment. Okay, um, they go for the installation of, even they have some solar powered electric vehicle charging stations, uh, especially in the places like Navi Mumbai and all. You can see they're going for this thing where they're it's again sometimes they also have the solar powered electric vehicle charging stations, by installing the kilowatt power capacity. Like it can be 16 kilowatt or 32 kilowatt, depending upon the vehicle category and how much time. Suppose if you go for high capacity, you can charge your vehicle in less time. If you go for low capacity, you need to have more time. The only problem with the residential thing is that the capacity means the power rating is going to be the normal power rating. You cannot increase the power rating. So that's why there is a possibility that the charging time can be higher. So that is also one of the things. But the researches are happening to increase to reduce the charging time, and also to increase the capacity. But again, the safety is also very important. um, if you want to increase the charging time, say if you want to reduce the charging time, and if you want to increase the capacity, that too from the electric capacity what you have from your residence. Okay, there is again safety aspects, those things also there. That's why it is better to go with a normal common charging system, where it is already been used. But nowadays, rather than, what I suggest is, rather than going for the individual home application, you can have a kind of a common within your apartment itself, where you can reduce the charging time and increase the power capacity as well. Because if you have the individual more capacity for your own individual residence, then again, the looking at the safety aspects, even that also be challenging again.
Thank you for the answer, sir. So we have one more question. It's a last question. To pursue a career in electric vehicles, what are the skills that are supposed to be learned by a mechanical engineer who's not having electrical background? This is the last question, sir.
This is what I also said during the start of my presentation also. Since everyone is mechanical background, what I suggest is to pursue a career with respect to the electric vehicle. What I suggest is, first you can look into your own subjects, like where you study the materials, metallurgy. Okay, so this is where you need to look into first your own area. Okay, the design aspects. And again, other skills, what you can look into is the electronics aspect, where you can learn some of the power electronics. Okay, and the electrochemistry, the battery management system, where you can learn how the chemistry is, because the battery technology keeps on changing. Previously we had a lead acid battery, now we have a lithium ion, we have lithium ion phosphate, we have lithium ion polymer going to come now. And even I told you about IIT Bombay, where they have done a research about the dual carbon battery. So these battery technologies keep on changing, where you can also upgrade yourself with respect to the battery, the electrochemistry applications. And this is very important. Okay, the thermal management, how you are going to cool your electric vehicle with respect to the thermal management, because you are going to experience a huge heat coming out of your battery system and your vehicle. So how you are going to reduce your heat or the thermal management? So with respect to whether you're going for a liquid cooling or a air cooling, that is quite normal for a two wheeler and for a three wheeler application. But especially when you go for a four wheeler, what type of liquid cooling you need to use it for the thermal management? Even this is also a good area where you can look into it. As I said, power electronics is a very good skills you can get it. And yeah, how the selection of a motor. I told you about different type of motor, AC, DC motor, and then you have the BLDC motor, and in brush motor you have permanent magnet, shunt motor system. You have different electrical motor. You can learn about the different types of motors, different speed, different torque which it can operate. So those things also you can upgrade. And again, this is like a common, like being a mechanical engineer, you should also understand the different vehicle engineering aspects. Like apart from this battery or a motor or a controller, you should understand the different vehicle aspects as well, like how it is getting integrated, how the tire or the wheel or the chassis or your brakes, suspensions, um, or a powertrain. Okay, so how it is getting integrated with respect to the complete vehicle. So those things analysis you need to look into it. You can get just an overview. Okay, and very important thing is this is very important. But even the electronics engineer or the computer science or software or IT, they are also not getting upgraded in this one. You need to look at some of the programming aspects because it's the controller. What I was telling, the controller for those things, motor controller, because you need to control your motor with respect to different conditions, different torque. So for those things, you can also upgrade yourself by learning some of the algorithms, some of the programs kind of things as well. But I see this is the area where many of the engineers are not concentrating, and you have very good scope. Okay, even in the you being a mechanical engineer, or you being a electronics engineer, or you being the computer science engineer. But what I feel is this area can also still more give more focus, because all these other areas are quite normal, and everybody is concentrating on. They come to know about many of the things, but this is where the area where where you can also add some additional skills, where you can show your uniqueness to the recruiter, where you can also domain your where you can get your area career into these areas as well. And again, this is again completely, but again, there are a lot of challenges to learn this one. Because even the people who is working in industries also finding it difficult, because they are going with some consultancy to understand all these things. But still, this is also a good area where you can get to your knowledge. But what I suggest is being a student, it will be difficult for you to directly go into this area. But what I suggest is you can get into the knowledge of power electronics, battery management system, and the motors. And apart from that, the vehicle integration, vehicle engineering, and the materials of your vehicle. So those things you can get, and there are a lot of good opportunities for the things. As I said, you have different areas: two wheeler, three wheeler, four wheeler, and commercial vehicle, where we are going towards electrification. As per the government, in the year 2023. Uh, all the three wheelers, basically the electric rickshaw, auto or rickshaw, what you call, that is going to be um, electric vehicle. Okay, in the year 2023, it means down the year of 2 years. All the autos will be of three of electric vehicle. That is as per the government norms, or as per the norms that is been given as per the government order. And in the year 2030, all the two wheelers will be converted to electric vehicle. Means either it can be by changing from IC to the electric vehicle, or it will be a pure electric vehicle coming from the OEMs. It can be from Mahindra, or it can be from Bajaj or Yamaha or Hero Motocorp. or Ether is already doing it. So you have, see, which means year 2023 you have huge market for a three wheeler to come in electric vehicle, and in the year 2030 you are going to have a huge market for the two wheeler segment. And again, as I was telling, there is a problem with respect to the charging system. Okay,
So,
as far as charging system is concerned,
so we have another session to
yeah,
start. So yeah, so
yeah,
we are
sure,
already
yeah,
40 minutes delay. Sorry.
yeah, sure.
Yes, sir. Because the
Yeah,
same
so
set of
you have very
students
good
need to.
opportunities, and
Yes, sir.
yes, yes.
Thank you.
Thanks, sir. Thanks a lot.
Thank you so much, sir.
Thanks.
Thank you for your time, and thank you, students, for your time. Thank you, sir.